next speaker today is Joel Cuello, and I am trying to cut down on my introductions, even though I enjoy them, and I hope they give you interesting information. So, and I just got thumbs up. So shut up quickly. Oh, okay, information. Miscommunication. So if I had to use one word that typifies and characterizes our next speaker, Joel Cuello, it would be bioimagineering. I've never heard of this word before, and I think you invented it, right? Yes. So this is an amazing thing because it includes biology, it includes imagination, and it includes engineering, all things that Dr. Cuello has become an expert in and has propagated, again, also on an international scale. I was really struck by the fact that Dr. Cuello, having had his career development as an engineer, is really what I call a Renaissance man. He is interested, I won't say what he's not interested in, you can read it in this piece, but he is interested in, he likes creativity, travel, communication, learning, imagination, feeding the world, and thinking about clean water. Now those are all very lofty kinds of purposes and objectives, but having grown up professionally as an engineer, he's also very much in touch with solving problems as an engineer, getting into the field and doing the work to solve some of the problems that he'll be talking to us about. And today he's going to be focusing on minimally structured, modular, prefabricated, vertical farm designs, version 2.0. So it must be that version 3.0 is still coming up, but he'll tell us all about it. Thank you for coming.
All right, so again, I want to repeat, thank you so much, Rafi, for such a very kind introduction. And Jin, thank you. I appreciate the opportunity to be here this afternoon to be talking with you. So because of the limited time, I'm just going to go straight to the point here. So many of you already are familiar with some of these numbers here. There's going to be 9.5 billion of us here on the planet by the middle of the century. To put that in perspective, it's like adding another China and another India on our current global population. So you can just imagine the enormous amount of pressure it's going to exert on all of our resources on the planet. To feed us today already takes almost half of the land surface of the planet. 2/3 of the Earth's 1% fresh water that's available to us is already being used in agriculture, and the food sector consumes about 30% of the world's total energy demand. So the bottom line is that going forward, we must produce more food, but with less land, less water, and less energy. That is the tall order that is confronting us today. There's one more important trend here. It's a demographic shift from the rural areas to the urban areas. Today there's about 4 billion of us out of 7.5 billion people living in cities. But by the middle of the century, it will be about 7 billion people living in cities out of about 9.5 billion. So farming around cities vertically will produce food with less land, less water, less carbon emission, and greater yield. This is the promise of vertical farming. So vertical farming is not a panacea. I'd like to emphasize that. It's not going to solve all of our food problems. It's not promising to produce all the food that mankind will need by the middle of the century. However, it's not insignificant either. As you know, we already have a small remainder of arable land that's remaining for us. And so since crop production will have to double by the middle of the century, we can then produce food such as vegetables and some types of fruits using non-arable land, and that's by using vertical farms. And therefore, we can dedicate whatever is remaining of our arable land for producing cereals and staple food that really are more conducive to open field cultivation as opposed to indoor agriculture. So because of the limited time, I'm just going to focus on 3 cornerstones of success for vertical farming in the vertical farming industry. And first, I'm going to talk about economic efficiency. And there's a formula here that I'm associating with this, E equals m squared P, which you will know just in a moment what it means. But just going back, let's talk about vertical farming 1.0. Dixon DePommier, a professor at Columbia University, published this iconic book now, The Vertical Farm, back in 2010, where he proposed growing crops indoors in cities. Now, this fired up the imagination of a lot of people, including architects, with good intentions. And so they came up with a lot of these beautiful designs, futuristic designs like this. Okay. The only hitch is that most of these vertical farming 1.0 concepts and designs are based on those for conventional buildings for people. And that makes vertical farming prohibitively costly. So in other words, if you use a vertical farm building that is designed specifically for human occupation, as what you would do in normally designing a building, and then use that just for vegetable production, it's not going to make sense economically. And so there's a need for vertical farming 2.0. And so this is where this formula E equals m squared P comes in. E stands for economic efficiency. And I'm introducing here the minimally structured, modular, and prefabricated vertical farm, which I'm also calling as the vertical green box solution. So what does minimally structured mean? Well, we don't have to design the building the way we would design a building for human habitation or offices or other human-rated purposes. So that means reduced load-bearing requirements because we're only designing this for crop production. Reduced services in terms of electrical services, plumbing services, and so on and so forth. Reduced materials and reduced total weight. And they would directly translate into making this building certainly much more economically feasible compared with conventional buildings. At the same time, you could design the building such that it could be assembled or disassembled. In Singapore, which is a very small, city-state, they have zoning for agriculture, which is a very small fraction of their land area. But because the land there is really high premium, sometimes the government would change the zoning. So if you built a greenhouse or a fixed structure for agriculture in one location, after a few years, that may be zoned differently for non-agriculture application, and so you're going to have to move. So it makes sense for some vertical farming structures to be amenable to disassembly and portability. Can low diverse growing systems apps? Okay, modular. Uniformity in growing space, hardware, environmental control, consistency of operational procedures, and therefore interchangeability of units, allows the use of varied growing systems, and allows development of turnkey operations. So those are the common advantages of having a modular unit-based structure. And prefabricated, it will allow for off-site construction and assembly of modules, and therefore it's going to be safer, and it's going to be more economical when this is assembled within a city or around or outside cities. And of course, it allows for vertical configuration. Think of Lego blocks. There's so many things that you can configure out of those building blocks. It's the same thing as well, the same principle for modular vertical farming units. You could have, for instance, a cylindrical configuration. You can have a linear configuration, or you can have a pyramidal configuration. And these are by no means the only ones that you could come up with. And at the same time, we're treating the vertical farm on the right structure as a platform or an operating system. And then all of the cultivation systems that you can put inside each of those modules, you can treat them as growing apps. So therefore, this is agnostic when it comes to the particular cultivation system that you prefer to use for growing crops. And the industry, therefore, could be mobilized in terms of designing perhaps the most efficient, the most optimized cultivation system that could be put inside each of those standardized units. All right, so there are so many megacities on Earth today with population exceeding 10 million, others 20 million. There are many megacities in China today, as well as in India. This one is an aerial view of New Delhi in India. And it's a megacity, lots of people, exploding with people, and characterized by extreme scarcity in certain resources, including water. And so that is why in India today, there is a big drive or push for efficient crop production systems, including vertical farms. And so one of the enterprising entrepreneurs in India today who has some really passionate vision for sustainability is Mr. Manikandan. And he reached out to me about the vertical green box solution. And he asked for permission to develop it commercially using his company. And so I was happy with that. So I will be serving as a scientific advisor to his company. But he's already starting to make some innovative designs using this modular type of construction. All right, moving on to the second cornerstone. The vertical farm, for it to succeed economically, should be not just economically efficient, but it's got to be socially responsive. So what do we mean by that? So we can apply what I call the SANE test. And that's an acronym. So S stands for safety of food. I'm sure you're familiar with the food scandals that rocked China in recent years about their food products which were not safe, including those for infant formulas and even crops. And so this has really created a high level of consciousness and awareness among the public in China to really make an effort to know how and where their crops are being grown. And so I was in China for the Vertical Farming Summit 2 years ago. And that's where I got impressed by a lot of stories that there are these huge greenhouse facilities, vertical farming facilities located outside of Beijing. And families would go there over the weekend. They would be willing to drive, a certain number of miles to go there on the weekend just to make sure that the crops that they are going to use to feed themselves as well as their children are safe. And at the same time, this has become some kind of a tourist attraction as well because the plants are so beautiful. So it's not only that they're sure that the crops that they're getting are safe, but they're also getting some kind of an education, entertainment, leisure during the weekend when they make these trips. Okay, A stands for access to food. And access means geographic, economic, and social access. And so since this is meant to be within urban centers or around urban centers, then certainly that's going to facilitate the access of food to urban residents. The USDA has defined certain areas as food deserts. So those are the areas in cities or around cities that do not have grocery stores that sell fresh produce. They only have convenience stores, and essentially these are the kind of food that you can get from those suppliers. So it's very important that vertical farms would help provide access to nutritious and economical food. N stands for neighborhood building and strengthening. And this is one benefit of vertical farms in urban areas or around urban areas because they can be used as a to catalyze the building of a neighborhood spirit or community spirit among residents. And of course, E stands for equity. Equity for the entrepreneurs and equity for the entire community. Because when businesses become successful, there are taxes and they flow back to the community, and it's an upward spiral from there. So that's the same test. Then finally, and I can't overemphasize this enough, it's important to link performance of vertical farms to sustainability. Because again, I began this talk by highlighting the enormous pressure that our planet is facing today in order to be able to produce the amount of food that we will need by the middle of the century. So we need a sustainability-linked performance. So I did my postdoc at NASA Kennedy Space Center working on space farming, which is controlled ecological life support systems. And so, since I'm getting older now, so over the decades, I've witnessed, and I'm sure you have witnessed as well, the advancements in technologies that are being applied in indoor agriculture. So that includes lighting, that includes monitoring, that includes sensing, and that includes control. And today, the amount of technology that's being used in indoor agriculture, particularly in vertical farming, is very dense. And so there is that trend over the decades of increasing technology density. And so this is where I'm taking responsibility for Cuello's law, that the projected industry goal that crop productivity with respect to resource use in a tech-dense indoor farm or vertical farm should double every 4 to 5 years. So, and it's not just a simple correlation of increasing technology density equals increase in productivity. I'm talking about increase in productivity per unit resource use. So in other words, kilograms of produce per liter of water, kilograms of produce per watt of electricity, kilograms produce per kilogram nutrients, per square meter area, and per cubic meter of volume. This all should double every 4 to 5 years as the technology that's being used in vertical farming is becoming more dense and becoming more efficient and powerful. So in this regard, I'm working with the Vertical Farming Association, or VFA, to develop a vertical farming sustainability registry network whereby companies can voluntarily report the productivity per unit resource use that they are achieving in their plants or in their businesses. And the hope here is that this will provide an impetus for the industry to help achieve this goal, this industry goal. And of course, there's going to be recognition provided to companies that achieve breakthroughs in their productivity. I'm not ready to talk about the details, so the Association for Vertical Farming will be providing some announcements, hopefully in a few months. We're still working on it. So in summary, the 3 cornerstones of success for vertical farming include economic efficiency, social responsiveness, and sustainability-linked performance. I thought I just would like to give a tribute to Professor Toyoki Kozai. He recently published these 2 books that he edited, but he really is probably, in my view, the first father of vertical farm. Now, of course, he had the benefit of standing on the shoulders of those who pioneered greenhouse hydroponic production. One of those pioneers, of course, is here with us, Merle Jensen. Yes. And of course, I'd like to acknowledge, of course, Dixon DePommier as well. His main contribution, in my view, is that he helped bring to the mainstream the concept of indoor plant production or vertical farming, which in Japan is called plant factory. So I have to give credit where credit is due. I just want to give a shout out to my student team who's working on the Arizona Green Box. They're called the Cats in the Green Box. And we're going to develop some innovative cultivation systems that are appropriate for modular systems. So I want to end by recalling this fictional astronaut whom I'm sure you're all familiar with. So there's this astronaut guy. He found himself one day alone on the planet Mars. And so he built a greenhouse, which is very rudimentary. He planted some potatoes. He was happy. But then there was an explosion. it killed his potatoes. So he was no longer happy. So in the future, so in future Mars mission, it's very important that we also introduce a minimally structured, modular, and prefabricated vertical farm that's really suited for the Martian environment. So finally, I just want to say, or want to give thanks to my lab group, and thank you for listening. Kevin. Yes. Hang on, so the people on the line can hear.
You didn't mention any difficulties with the fish productions, such as disease. What is the current state of disease and dealing with that?
Sure. Yeah, there certainly are disease issues with farm-raised fish, farm-raised shrimp. As a matter of fact, we have the world's premier shrimp pathology group here at University of Arizona. So just as with any other terrestrial agriculture, we have plant diseases, shrimp diseases, fish diseases, and we're working with the technology. Again, we're taking lots of technology that come from human diagnostics, genomics, all this work that's been developed for human pathology and diagnostics, and we're applying it to aquaculture diseases. Just as they are plant diseases in greenhouses and vertical farms will have all the same issues, but again, the technology's coming along so quickly it really helps us to keep ahead of it. Yeah.
Initially, there was an association with shrimp farming and damage to estuaries. I just wonder what the current status of that is.
Yeah, good question. When shrimp farming first got started, a lot of it occurred in mangrove areas because that's where the shrimp naturally were. So people assumed that was a good spot. So they were bulldozing mangrove swamps and building ponds. It turned out pretty quickly that that's a terrible place to try to farm shrimp. You're subject to floods, tsunamis. The soils in these are very acidic, so it's not a very good place to be farming. They're full of birds who all like to eat shrimp, so that became problematic. Now most farms are actually in plastic-lined ponds that they build quite a ways inland, and it turns out most of these shrimp can do fine in salinities that are just 2 or 3 parts per thousand, so 1/10 of seawater. So they just need to put a little bit of salt in there. You grow the shrimp up, and it's not near the problem that they had. Almost every country in the world has outlawed cutting mangroves for shrimp farming. So, yeah. Hang on. There you go.
Kevin, why don't you tell this group, you talked about tilapia, but tell this group the role of the University of Arizona in shrimp farming today, how that Puerto Peñasco works.
Sure. Well, the University of Arizona was one of the pioneer research groups on both shrimp farming and tilapia farming. The shrimp farming started back in the 1970s down in Sonora, Rocky Point, Puerto Peñasco, with the first attempts to reproduce the Mexican blue shrimp was first domesticated at those farms down there in Sonora, which eventually grew into quite a large industry in Mexico, but became a big industry all around the world. About 2/3 of all the shrimp in the world now is farm raised. And all the disease work was developed here.
I have a question for Dr. Cuello. One of the limitations at least apparent limitations of vertical farming is the crop size, the height of the plants. I've seen some images of plants growing upside down, which creates another problem, that of leakage of nutrients. But could you talk a little bit about the issue of limitation on crop size?
Right. This may be biasing you because I showed you a picture of a shipping container, which is a modular unit, the most probably common modular units that we see around. But a module here is not limited in dimensions to that of a shipping container. It can be as big as this room or larger than this room. Now, having said that, it's correct. You can increase your productivity better if your plants are shorter as opposed to taller, so that you can minimize as well the vegetative growth of the crops that you're growing. If you're growing crops that have less vegetation or vegetative parts as opposed to the fruit or the crops that you're interested in, that would be better. Of course, for salad crops, that's another point. But yes, so in other words, there should be some plant breeding associated in terms of perfecting and optimizing the performance of a vertical farm. And perhaps even genetic engineering, it cannot be ruled out. Other questions for Kevin or me? Don't be shy.
Excellent presentations. Thank you very much. For Joel Cuello,
Okay, Gene.
if you would. You speak about vertical farm in containerized, controlled environments using hydroponics, I presume in some manner, for producing food in the cities or in the urban areas. Can you speak that relative to other options of growing food in urban areas,
Right.
About the concept of urban agriculture,
Correct.
where
Yes.
this vertical farm or indoor growing could be one way to do it. Have you investigated that, and does it suggest that this is the more optimal way to do it?
Okay, and that is a very good question and point for clarification, Gene, because urban agriculture is not just vertical farming. There's quite a number of versions or manifestations of urban agriculture, one of which is a community garden. It could be rooftop greenhouses, or it could be a vertical farm. So it depends on the particular city, its architecture, how the buildings are, their dimensions, whether there's available rooftop, and so on and so forth. So all of those, I have to say, should be pursued. And whichever makes economic sense, definitely it should be pursued, whether it's community garden or vertical farming or rooftop greenhouses. The advantage of vertical farming is that it can really be designed in such a way that it could be a standalone. So you don't have to be dependent on the architecture of a particular building. And again, as I try to emphasize, this does not have to be located right inside the city, because the challenge there is that real estate in cities typically is of very high value. So it wouldn't make sense to do it right in the middle of Manhattan, perhaps, building a new building specifically for vertical farms. So just outside the city, around the city, or a certain number of miles from the city would be fine, just like airports. More questions for Kevin? How about online? Do we have questions online? All right. Okay, so we really appreciate this. So thank you so much. Thank you.